Hey everybody, it's Mrs. Bianchi. We're looking at number 2, which is a little tricky, so I thought I'd give you some help on it. And I also thought it might be a good idea to actually talk about this polyhedron as a three-dimensional thing, because sometimes looking at it as a two-dimensional drawing can be a little tough. So we're going to talk about it in the context of, I made a shape that's similar to it, so you can see that it's a triangular prism. And how do we know it's a triangular prism? So in class we've been talking about if you spin this thing around and hold it, my top finger is on one of the bases, my thumb is on the other base, and if I spin this thing around, you can see that we have rectangles as lateral sides, and the bases are equilateral triangles. So look at the image of it, and let's try to figure out how we're going to find the surface area of this thing. All right, so first of all, let's talk about how do you find the area of one of the triangles. The formula for one of the triangles would be area equals half of the base times height. But we have two of them. We have this one and we have the one in the back. And if we look at the polyhedron, we have the one in the front and we have the one in the back. So we have two of them. That's why we're going to multiply all this by 2. Let's substitute in the numbers. Area equals 2, because we have two of them, times half times the base of this thing would be right here. This line right here would represent the base, and they're telling us it's 6. And the height has to be perpendicular to the base. So see this dotted line? 5 2/10. Next, let's take half of what we can in our heads. Let's take half of this, which would be 3. And then we have to multiply that by 5 2/10. And remember, we have two of these things. Now, when you get to this point, I'm going to multiply these two things first, just so we understand what the area of one of the triangles would be. But you could do this times this first, then multiply that by 5 2/10, and that would give you the area that would cover both of the triangles. But I'm going to do this first, just to help folks understand what's the area of one of the triangles. Let's take out our trusty calculator. Calculator right here. And the numbers that we have to multiply again are, we're multiplying 3 times 5 2/10, 3 times 5 2/10, and we get this number, 15 6/10. This times this, we got 15 6/10. Now we have to take that number, that's the area of one of the triangles. Let me write it on one of the triangles so we can see it. It's 15 6/10. So we have two of those. So if we take the calculator and multiply that by 2, we'll get the area of both. Let's see if I can move that up. All right, and we get 31 2/10 for the two of them. This times 2, we got 31 2/10 square centimeters for the two triangles. All right, so that covers this piece and it covers this piece. All right, so let me erase this so we don't get confused. Now let's talk about the rectangles. So let's start by talking about the one that we might think of as the floor of the tent, this one right here. Now, what are the dimensions of that? Now, if we look, my lights just went off. I got to move to make them go. There they go. All right, so if we look at our equilateral triangle, what would be true about all of the rectangles on this thing? If you look at them in the image, what would be true? Perhaps looking at the net. So I have a photocopy of the net. If you look at the net, aren't all the rectangles, aren't they all congruent and equivalent if we're talking about an equilateral triangle as the basis? So that means that each one of the rectangles would be equal and congruent. And more confirmation of that is the idea that if this is 6 and this is 6 and this is 6 over here, that confirms that it's an equilateral triangle, which means that all the rectangles that would make the lateral sides would also be congruent. So what are the dimensions of them? Now remember, we have 3 of them. So let's put down the area for a rectangle, which is base times height, but we have to remember that we have 3 of those. And what are the dimensions? The dimensions are, here's one of them, that's going to be 14, and then the other dimension would be right here, which would be 6. Now again, if you look at the actual three-dimensional polyhedron, they're saying that this is 14 right here, and they're saying that this edge right here would be 6. So if it's a 14 by 6 rectangle, and I'll spin it around, they're all going to be 14 by 6 rectangles. We have 3 of those. Now, if you're not seeing it in the picture, allow me to highlight them for you. So we have the one on the floor, we have this one right here, and then we have the one in the back. Now keep in mind it's artist perspective, so the one in the back would be this one. So that's that third side. Artist perspective, it doesn't look like a rectangle, but it is. So if we find this product, then we're going to get all 3 of the rectangles. So let's take out our trusty calculator, and we can do 3 times 6 in our head. 3 times 6 is 18, so how about we multiply 18 times 14 just to speed things up. 18 times 14, and we get this number, 252. So that all equals that number. Now, if you wanted to show it, to show that you did that for the mental math, and then multiplied that by 14, that's always something that a math teacher would like, so that they can understand your thinking. And that number that we got again was 252, and that would be square centimeters. Now the only thing left you have to do, my lights went on again, the only thing left you have to do is you have to add this, which would represent the 2 triangles, and this, and then you'll have the right answer. All right, good luck finishing that up.